the cube root of negative 32 x squared y cubed. So I'm going to take cube root and I'm going to break it into two pieces. The front part is the cube, the last part is the leftover, and 32 is more unfamiliar to me. So I'm going to take my powers table and I'm going to look at going down the cubes and 32. So 64, 27, 8. Does 8 divide 32? Yeah, so the biggest cube that's in 32, because you start from the bottom and work your way up, is 8. And because I've got a negative, it's a negative 8. And then the leftover is 4, because 4 times negative 8 is negative 32. X squared doesn't have an x's, so he's on the leftover. You have to have at least 3. And y cubed is a cube.
So
yes?
When it's a negative, the negative always goes inside, and it's never like negative.
For the odd index, yeah.
Okay.
Yeah, because you can take the cube root of negative 1, because negative 1 times negative 1 times negative 1 is negative 1. If it were square, then basically you would say it's not a, or 4, it's not a real number, so the negative can't go anywhere. It just stays where it is because you can't do anything with it anyway.
Okay.
At least not yet.
Great.
So we have then, we break it into two pieces, the cube part and the uncubed part. The cube root of negative 8y cubed is just negative 2y. Now remember, when I broke it apart, this is a multiplication that's there. And then you have the leftover, which is 4x squared. Now I make sure that you put that little 3 inside that v, so you don't think that what you're doing is taking 3 times negative 2. And that's what happens, because you get it too far outside or you get the little 3 too big, and before it's all over you think that you are multiplying the 3 times, and especially in test situations. Okay, so we no longer have the little chart here that tells you how to do it as we move down to multiple roots of different kinds. So it says, assume all variables in a radicand represent positive real numbers and no radicands involve negative quantities raised to even powers. Now, what does that mean? What that means is that there is an answer. Okay, because remember that what we're looking at is that if I had a negative under an even index radical, that there would be no real number. So they're basically saying, okay, things are nice. There's going to be an answer to this thing. Because if any x value I put in there is going to give me a number coming out, then I'm fine. It's not going to. I'm not going to be taking the square root of a negative number. I'm not going to be taking the fourth root of a negative number. We're okay. But we just ignore it and do our homework. So I'm looking at the square root of 64, x to the 7th, y to the 16th, and I want to break him into two pieces. So I'm going to take this guy, break him into two pieces. The fifth root and the leftovers. Now, 5s I'm not familiar with, so I'm going to take my powers table, and this is n to the 5th is now what I'm going to use, and we're looking at 64. And so I'm going to cover up everything else so I don't confuse myself, because if the index is 5, I use the 5s column. And 32 is the only possibility. Does 32 divide 64? Yes. And 32 divides 64, and so 32 is the thing that's to the 5th power, and then 2 left over because, and I need more space. 32 is to the 5th power, and then I have 2 left over. And I'm going to take this thing out. problem when you do it in pen. And then I look at x to the 7th. Well, I need the largest number because I'm dealing with multiples of 5. So that says the largest number that's a multiple of 5 before 7 is 5. So this would be then x to the 5th power, and I have 7 of them, and that means I have 2 left over. And I've got 16. So the biggest number that's a multiple of 5 before 16 is 15. So that's y to the 15, and then 1 left over because I had 16 of them. So now this is the leftover. It's going to be the 5th root of 2x squared y. And now I take the 5th root of the front. 5th root, and see I forgot my index already. 5th root of 32 is 2. 5th root of x to the 5th is x to the 1. 5 divides 5 how many times? 1 time, right? And then y is 5 divides 15, 3. And so then that's your answer. That's as simple as it gets. Now, I've got the 4th root of that set of parentheses, by the way, to the 14th. I do not care what's in that set of parentheses. The whole thing is the radicand. To me, it's like a giant blob to the 14th. So when I look at this problem, I have 2 pieces, and this is the 4th root. I have a set of parentheses and a set of parentheses. I'm looking now multiples of 4. What's the biggest number that's a multiple of 4 before 14? 12. So this is to the 12. I have 14 of them. That's to the 2. Now I care what's on the inside. I really don't care at this point what's on the inside. I do my final answer, but the inside happens to be x minus 2, so I don't forget. So the leftover is the 4th root of x minus 2 squared. And 4 divides 12 how many times? 3. So this is x minus 2 cubed. So you have to be very careful about these two numbers. This guy's an exponent, that guy's an index.
How come you didn't put him in the square root?
This is the leftover.
Okay, no, okay, I understand that part.
What I didn't do is put the intermediate step in. To get from here to here,
Okay.
this would have been
I see.
the 4th root of the set of parentheses to the 12th times the 4th root of the set of parentheses squared. And then from there, you go to here.
Thank you.
Okay, fine. Oh.
Now, in order for me to simplify this guy, I have to multiply him first, so I have to bring it together so that this becomes the square root of 3 times 6, which is the square root of 18. Okay, and then 18 reduces down. I'm dealing with square root, so I have the square and the unsquare. What's the square in 18? 9, and then 9 times 2 is 18. So the leftover is the square root of 2. And then what's in front is the square root of 9, which is... That's the beauty of writing it front and back. So you kind of like cover it up. That's what's left over, so that's what's under the radical. That's what comes out. So I just did break it into those 2 pieces with the intermediate step. Same thing here. First thing I have to do is that I have to multiply these 2. So I know what I'm dealing with. This is 5 times 10, which is 50. X times x, which is x squared. Y times y squared, which is y cubed. Now, if you need me to put that step in, let me know. because I skipped a step. So I just multiplied these two radicals together. So now I'm going to break it down into my two parts. 50, what's the square in 50? 25. The leftover is 2, and dang it, I did it again. Don't have enough space. And the leftover is 2. X squared is a square. And y cubed, what's the square in y cubed? Y squared, and then I've got 1 left over. So if I look at this, the leftover is the square root of 2y. And the perfect square part is this guy. And what's that? 5xy. Kind of why I said yesterday was pretty pivotal for this set of information. So, now notice I've got stuff on the outside. This is really, because these are all multiplications, this is 3 times the radical, 5 times the radical, and so they're all being multiplied together. This is really 3 times 5. I'm just going to reorganize them using the commutative property of our number system. The square root of 15, the square root of 6. Because everything's being multiplied. Yes?
So can we just multiply the 15 to 6 and we're doing 5?
Oh, sure you can. Yeah. I just wanted to make a point. And sometimes I put more in than what I would do normally. And that means that the numbers get multiplied, so that's 15. And under the radical, it's 15 times 6. So you can bring the radicals together because they have the same index. So this is 15, the square root of 90. And now I can, this is where you need to kind of dot your I's and cross your T's because things become very detailed. This is 15 times that radical. That means it's 15 times this radical can be broken down into the square and the unsquare. The square is 9 and 10. Now I'm going to put the step in that I haven't been putting in, again to make a point, because this is 15 times, the square root of 9 is 3 times the square root of 10. This one breaks down into 3 square roots of 10. And then the whole thing gets multiplied by 15. This is 15 times that radical. 15 times that radical. That radical got broken down into 2 pieces, which happens to be a multiplication itself. So now I've got this multiplication. So this then becomes 45, because the 2 numbers multiply together, square roots of 10. That's the most complicated part about this particular set of material, is when you start having these extra things hanging around the outside, which we'll see when we add and subtract this stuff. That's why, if need be, put a lot of steps in. Because it's when you try to be quick about it that it ends up being much more of a problem. Now I'm dealing with cube root. And there's nothing hanging out in front, and then I say yippee to that one, because it's a much less complicated problem, except cube root is more complicated. Now, under the single radical, I'll have 6x to the 7th y times 9x to the 4 y to the 12. 6 times 9 is 54. X to the 7 times x to the 4 is x to the 11. y to the 1 times y to the 12 is y to the 13. And we're dealing with cube root. And see, I forgot my indexing. Most of you will. And now we can break this down into two pieces. I'm going to try to now leave myself enough room for a change. And what is the square in 54? Square, or cube. Cube. 27. Thank you very much. 27 and 3. That's not 54. And then what's the cube in x to the 11th? X to the 9 with 2 left over. The cube in y to the 13th is y to the 12 with 1 left over. So now this guy's in two pieces. You have the leftover. See, if I had powers of 3 or higher left in my leftover, I'm not done. That's got to be power of 2, power of 1. Because power of 3, which means I can take the cube root of it. So now we take the cube root of 27, which is 3. The cube root of x to the 9th, which is x to the 3, because 3 divides 9 3 times, and y to the 4. This is the thing. When you're dealing with the index really is an exponent. Remember, it's 1/3. If I go to rewrite that radical, it would be to the 1/3 power. It's really an exponent. That index, being an exponent, will only interact with exponents. That's how exponents do. Exponents only interact with other exponents. They never interact with numbers. The coefficients. Yes?
On the test, if we forget the index is a whole
You lose a point. I know. Because it makes it a different answer. If I would have said instead and left it being a square root, I would have had a problem because x squared is a square and I wouldn't have been done. And that's why even, yes, do I forget it, you forget it, I have to go back and cross-check to make sure. Yeah, unfortunately. Oops.